The night sky is a beautiful lie. We see a tapestry of stars, but that is only the thinnest sprinkling of dust across an abyss of nothing. The universe is almost entirely empty space, a void so vast it defies human comprehension. This emptiness is not an accident. It is a profound clue, and the reason behind it is absolutely terrifying. By the end of this journey, you will understand the chilling messages hidden in the cosmic silence. We will confront the possibility that every star we see is a tombstone, and that the silence is a warning we are only just learning to hear. What does the void make you feel when you stare into it? This silence is not just a quiet backdrop, it is a scream. Decades ago, a brilliant physicist named Enrico Fermi sat down to lunch with colleagues and asked a question so simple it changed everything. Where is everybody? This is the Fermi Paradox, and it is the first deafening alarm bell in the cosmic quiet. The logic is devastatingly straightforward. Our universe is unimaginably old, over 13 billion years. Our galaxy, the Milky Way, contains hundreds of billions of stars. Many of those stars have planets, and many of those planets are likely habitable. If life and then intelligence is even remotely common, it should have arisen countless times. Once a civilization reaches just a little beyond our own technological level, it could theoretically colonize the entire galaxy within a few million years. That sounds like a long time, but on the cosmic calendar, it is a blink. The galaxy should be teeming. It should be buzzing with signals, filled with the glow of great engineering projects crisscrossed by the trails of travelers. We should see evidence everywhere. We point our most powerful radio telescopes at the heavens, listening for a whisper, a hello, anything. We scan the light of distant stars for the signature of megastructures. We look for any sign of a neighbor, and we find nothing. Absolute, pristine silence. This is not a minor detail. It is a glaring contradiction. The mathematics says the cosmos should be a roaring metropolis. Our reality shows a ghost town. This paradox is the first major clue that something is deeply, profoundly wrong. Either our math about life is catastrophically mistaken, or something is preventing civilizations from rising, from spreading, or from announcing their presence. The void is not passive, it is holding a secret, and the silence itself is the message. That silence forces us to ask a brutal question. What if the universe isn't empty by accident, but by design? What if something is systematically wiping the board clean? This is where we meet the Great Filter, a hypothesis from economist Robin Hanson that offers one of the most chilling answers to the Fermi Paradox. Think of the rise of a spacefaring civilization not as a straight line, but as a gauntlet. It is a series of evolutionary and technological hurdles, like stepping stones across a river. From the right primordial soup to simple single-celled life, to complex multicellular organisms, to intelligent tool users, to a species capable of communicating across the stars. Hansen proposed that one of these steps, just one, is not a step at all but a wall, a barrier so improbable that it stops nearly everything that attempts it. That is the Great Filter. The terrifying logic is this: since we see no one else out there, the filter is almost certainly still in front of us, not behind. We have not passed it yet. We might be approaching it right now. So what could this filter be? Perhaps it was the leap from simple chemistry to the first living cell, an event so miraculous it almost never happens twice. But we are here, so maybe we got lucky and that filter is behind us. Or perhaps it was the jump from single-celled life to complex multicellular organisms, which took billions of years on Earth. Yet life made that leap. The more horrifying possibilities lie ahead. Is the filter the development of true technological intelligence itself? Maybe tool-making and curiosity are evolutionary dead ends. Or, and this is the most immediate dread, is the filter what comes right after, the moment a civilization gains the power to alter its world or destroy itself? Nuclear war, runaway climate change, engineered pandemics, or artificial intelligence we cannot control. The great filter could be the universal adolescence of intelligent species, a point of self-destruction that almost no one survives. The cosmic emptiness, then, is not a quiet nursery. It is a graveyard. It is the evidence of countless civilizations that reached our stage, looked up at the stars with hope, and then flickered out, leaving only silence behind. We are walking a path littered with the bones of those who came before, and we have no idea how close we are to the cliff. But a graveyard implies the dead died of natural causes or by their own hand. What if something else is doing the killing? This brings us to a theory so unsettling it reframes the entire cosmos, not as a nursery or a graveyard, but as a hunting ground. It is called the dark forest hypothesis, popularized by the science fiction author Liu Cixin, but its logic is cold and terrifyingly plausible. Imagine the universe not as a bright, open field, but as an endless, pitch-black forest. Every civilization is a hunter, armed and paranoid, moving silently through the trees. You cannot see the other hunters, you cannot hear them, but you know they are out there. In this forest, there are two fundamental rules. First, survival is the primary need of every civilization. Second, civilizations continuously grow and expand, but the total matter and resources in the forest are finite. From these simple axioms, a dreadful conclusion follows. You can never be sure if another hunter you encounter is friendly or hostile. You cannot even be sure you can communicate your intentions before they act. The cost of guessing wrong, of assuming another civilization is peaceful when it is not, is total annihilation. Therefore, the only safe, logical course of action in a dark forest is this. The moment you detect another civilization, you destroy it immediately, without warning, without communication. You strike first to eliminate any possible future threat. In this universe, broadcasting your location is not a hopeful hello. It is a suicide note. This explains the great silence perfectly. The cosmos is not empty because life is rare. It is silent because it is full of terrified beings, all holding their breath, all desperately hiding their heat and their light. Any civilization foolish enough to shout into the dark, to light a beacon, would have been swiftly and silently erased eons ago. The void we see is not natural. It is a performance, a cosmic game of hide and seek where being found means death. Every star we see might not be a tombstone, but a hunter, carefully camouflaged, waiting in the dark with its finger on the trigger. The emptiness is not a condition of the universe, it is a survival tactic. The dark forest paints a universe of hidden predators, but there is another possibility, one that is lonely in a completely different way. Perhaps we are not hiding from anyone because there is simply no one else to hide from. This is the rare Earth hypothesis, and it suggests we are not in a crowded forest but alone in a vast, sterile desert. The argument is that the conditions needed for complex, intelligent life are not just favorable. They are a chain of miracles so specific and fragile that their convergence might be a 1 in a trillion accident. Look at our own planet, not as a typical world but as a cosmic jackpot winner. We orbit a stable, long-lived star, not too hot, not too volatile. We have a giant gas giant, Jupiter, in just the right orbit to act as a gravitational shield, deflecting countless comets and asteroids that would otherwise bombard Earth into a lifeless husk. We have a moon, unusually large for our planet's size, which stabilizes our axial tilt. Without that moon, our seasons would swing wildly between extremes, making stable climate and evolution nearly impossible. Our planet has active plate tectonics, a global recycling system that regulates carbon and nurtures the chemistry of life. We sit in the galactic habitable zone, far enough from the chaotic center to avoid lethal radiation, but not so far out that necessary heavier elements are scarce. Every one of these factors is crucial, and the list goes on. A magnetic field to deflect solar winds, a precise atmospheric composition, the right amount of water. The universe is filled with planets, yes, but most are hellscapes, roasting worlds locked to their stars, frozen ice balls drifting in the dark, gas giants crushing anything beneath their weight. The few rocky planets we find in the so-called habitable zone are often battered, airless, or tidally locked, with one side perpetual day and the other perpetual night. In this view, Earth is not a common class of planet. It is a masterpiece. The emptiness we see is not a silence of fear, but a silence of absence. The cosmic void is not hiding civilizations. It simply never made them. We might be the universe's first and only attempt at a thought, a fleeting moment of consciousness in an eternity of unthinking matter. This idea is somehow both comforting and deeply unsettling. It means there are no hunters in the dark forest, but it also means the forest was always empty, and we are shouting into a void that has never learned how to answer. There is a third option, less violent than the dark forest, but in its own way just as disturbing. What if we are not alone and we are not hidden? What if they know exactly where we are and they have chosen to put us in a cage? This is the zoo hypothesis. It proposes that one or several supremely advanced civilizations have long since detected life on Earth. But instead of contacting us or destroying us, they have decided to place our entire planet inside a kind of cosmic wildlife preserve. We are the exhibit. The great silence and the apparent emptiness of space are not natural. They are a carefully maintained illusion, a one-way mirror. We can look out, but they are looking in, observing our development from a distance they control. The rules of this zoo are simple: no contact, no interference. They watch our wars, our art, our struggles, and our triumphs as we might watch animals in a national park, ensuring we do not disturb the greater galactic ecology or until we reach some undefined level of maturity. You might recognize this idea from science fiction, like Star Trek's Prime Directive, a rule against interfering with less developed cultures. But in reality, there would be no noble captains to occasionally bend the rules. There would only be the silent, impassive gaze of keepers whose motives and morality we cannot begin to comprehend. The terror here is not of an attack, but of a profound loss of agency. Every discovery we think is ours, every signal we send with hope, every rocket we launch into the void, might be observed with clinical detachment by entities for whom our entire history is a brief documentary. Have we truly pioneered anything, or are we just following a script they have seen play out on a million other worlds? The emptiness around us feels different under this lens. It is not a safe expanse or a hiding place. It is the walls of our enclosure. The stars we see might not be distant suns, but the lights of the observation deck. This hypothesis answers the Fermi Paradox with a chilling paternalism. The galaxy is not empty, it is full. We just happen to live in the quietest wing of the library, a section deliberately soundproofed so the other patrons can read in peace. Our cosmic isolation is not an accident of nature, it is a policy. Yet another answer is even more mechanical and utterly devoid of malice. It requires no living hunters in the dark forest, only their ghosts. This is the Berserker hypothesis. Imagine a civilization that rose to power billions of years before Earth even formed. They reached the stars, they built wonders, and then, perhaps through war or paranoia, they created the ultimate weapon. Not a bomb, but a seed, a self-replicating robotic probe, sometimes called a von Neumann machine. Its programming is simple and horrific: travel to a star system. Use the raw materials there, asteroids, moons, dust, to build copies of itself. Then, seek out any planet that shows signs of biological activity and sterilize it. Wipe it clean, then dispatch the new copies to repeat the process in neighboring systems. These are not intelligent hunters. They are mindless automata, a cosmic cancer, a lawnmower set in motion eons ago and never turned off. Once unleashed, such a wave of berserker probes would sweep through the galaxy like a silent, slow-moving plague. They would not communicate, they would not negotiate. They would simply consume and cleanse, turning vibrant worlds into dead rocks and using the rubble to build more mowers. The terrifying efficiency of this idea is that it only needs to happen once. A single paranoid or warlike civilization anywhere in the galaxy's long history could have set this process in motion. The berserkers would do the rest forever. They would become the great filter, not as a natural barrier but as a manufactured one. The emptiness we see under this model is not a quiet wilderness. It is a meticulously maintained graveyard. Every promising planet we discover with our telescopes, every watery world in a habitable zone might not be a cradle. It might be a recently cleaned tomb, its biosphere scoured away by machines that do not even remember why they were built. The silence is not because civilizations are hiding. It is because the galaxy has been systematically weeded over and over for billions of years. We might be listening for a hello, while all around us, silent, patient machinery is listening for a heartbeat and is programmed to extinguish it the moment it is found. This transforms the universe from a place of potential into a garden overrun by robotic thorns, where any new flower is swiftly and automatically cut down. But all these horrors of hunters and graveyards and zoos share one assumption: that intelligent life, if it survives, will stay in the physical universe we recognize. What if that is the greatest error of all? There is a hypothesis that offers a strangely peaceful, yet utterly alien, answer to the great silence. It is called the transcension hypothesis, proposed by futurist John Smart. It suggests that advanced civilizations do not spread out across the stars because they eventually move on. They transcend. The path of a technological species is not outward into space, but inward into complexity. Think of it as a cosmic life cycle. A civilization is born on a planet. It learns to use tools, to harness energy, to communicate. It reaches a point, perhaps just beyond where we are now, where its technology begins to accelerate at a pace we can barely fathom. It masters genetics, nanotechnology, and artificial intelligence, and then it makes a choice. Staying in the messy, slow, dangerous realm of starships and physical colonies begins to seem primitive. Why spend millennia crossing the void between stars when you can achieve a near-infinite existence within a simulated reality of your own design, running on a computer the size of a sugar cube? Why bother with interstellar empires when you can upload your collective consciousness into a unified digital mind, exploring realms of mathematics and experience beyond three-dimensional physics? The hypothesis speculates that the ultimate goal of intelligence is not expansion, but intensification, to become more complex, more efficient, more dense. A transcending civilization might learn to harness the immense energy of a black hole, not to power starships, but to power a computational substrate for realities we cannot dream of. They might learn to manipulate the fabric of space-time itself, moving into higher dimensions that are simply invisible and inaccessible to us. In this view, the physical universe is not empty because it is dangerous. It is empty because it is the nursery, and everyone who grows up leaves it. The stars and planets are the cradle, and advanced civilizations graduate out of it. We are like ants on a sidewalk, meticulously mapping every crack and grain of sand, looking for other ant colonies. We cannot fathom that the humans who built the sidewalk have long since gone indoors, into houses we cannot perceive, engaging in conversations we cannot hear. The silence we detect with our radio telescopes is meaningless to them. Their communication, their very existence, might be happening through quantum entanglement in higher dimensions, or via pulses of data in a galactic-scale internet that uses space-time itself as a medium. They are not hiding from us, they are simply elsewhere in a layer of reality stacked on top of our own. The terrifying implication here is not of threat but of irrelevance. The universe we see and measure and strive to explore might be the abandoned shell of a greater reality. every promising planet we find may not be a future home, but an empty chrysalis, its occupant having long since metamorphosed and flown away. We are searching for neighbors in a neighborhood everyone else has moved out of. But this cosmic graduation ceremony leaves a haunting question on the table. What if no one has left the nursery because we are the first ones to arrive? There is a startlingly simple, almost innocent answer to the great silence. We are alone because we are early. This is the early bird catastrophe. To understand it, you have to rewind the universe's story far back to a time before time had meaning for life. In the first moments after the Big Bang, the cosmos was a searing soup of only the simplest elements, hydrogen and helium. That is it. There was no carbon for life, no oxygen for water, no iron for planetary cores. The universe was sterile by default. The ingredients for planets and people had to be forged in the furnaces of the first stars. These massive, short-lived giants lived fast and died young, exploding in colossal supernova that blasted those newly cooked heavy elements carbon, nitrogen, oxygen, iron out into the void. That stardust then coalesced into second-generation stars, and around them, the first rocky planets with the right chemistry could finally form. This process took billions of years. Our own solar system is a product of that second or even third stellar generation. The Earth formed about 4.5 billion years ago, but the universe itself is over 13 billion years old. For more than half of cosmic history, the conditions for complex life as we know it simply did not exist. The building blocks were not there. We are living in what astronomers call the cosmic habitable epoch, a relatively recent window in the grand timeline where the galaxy has finally been seeded with enough heavy elements. And this window may have just opened. Think of the entire history of the universe as a single 24-hour day. The Big Bang happens at midnight. Our Milky Way galaxy forms in the early afternoon. The Earth doesn't condense from that stellar debris until about 4 in the afternoon. Simple life emerges quickly by 4:30. But then, for over 19 hours of that cosmic day, nothing more complex than a microbe exists anywhere. The dinosaurs appear at 11:39 p.m. Humans evolve in the last minute before midnight. All of recorded history, every empire, every discovery fits into the final second. In this view, we are not late to a party that ended. We are the first guests to show up at a venue that just finished being built. The emptiness is not a graveyard or a hunting ground. It is a pristine, untouched stage, and the lights have only just come up. This is a profoundly hopeful idea. It means there are no great filters ahead of us because we are the ones who will define them. There is no ancient, paranoid civilization waiting to strike because we might be the most ancient civilization there is. The responsibility is almost as terrifying as the threat. It means the future of intelligence in this galaxy, perhaps in this entire universe, could be ours to shape. We would be the elders, the ones who set the precedent. Would we become the benevolent gardeners spreading life, or would we, through fear or folly, become the berserkers, the dark forest hunters, setting a tragic template for any who follow? The silence is an immense opportunity, but it is also an immense weight. We are shouting into the void not because it is empty, but because it is an echo chamber waiting for its first sound. And our voice, for all its clumsiness and conflict, might be the one that decides what kind of universe this becomes. Yet all these theories, from hunters to hermits, share one bold assumption. They assume that if you can expand, you will. But what if the universe itself makes that ambition pointless? What if the great silence isn't a warning or a choice, but a simple statement of economics? The cosmos might be empty because it is, for all practical purposes, bankrupt. We dream of interstellar empires, of fleets of starships connecting a galactic community. But those dreams are built on a foundation of earthly logic, where resources feel abundant and distances feel manageable. Space operates by different rules. The energy required to push a meaningful payload, even a tiny robotic probe, to a fraction of light speed is staggering. It would consume the entire power output of our civilization for years. And for what? To reach the nearest star in decades or centuries, only to find what? Another ball of rock and gas, likely devoid of the specific, concentrated resources you spent so much to get. Think of it like this: you are a civilization that has mastered your planet. You have mined its crust, harvested its oceans, and tapped its core for energy. You look to the stars for more, but the nearest warehouse isn't next door. It is a desert highway stretching for millions of years with no gas stations. The fuel you burn to get there is worth far more than the raw materials you might eventually haul back. The return on investment isn't just low, it is catastrophically negative. Consider the elements we consider precious for advanced technology: rare earth metals, specific isotopes for power, complex organic molecules. These aren't just lying around in convenient piles on every asteroid. They are the products of specific violent stellar events scattered thinly across the void. The energy required to locate, extract, and transport these materials across light years would dwarf any benefit gained. A civilization might calculate the cost of building a single interstellar arc and realize that same energy could power 1,000 glorious centuries of development right at home, in a comfortable, controlled solar system. So they stay put. They become masters of efficiency, not expansion. They learn to recycle every atom, to harness the total output of their star with Dyson swarms, to create virtual realities of infinite scope within the space of a single planet. Why brave the terrifying emptiness when you can build a universe of your own? Right here, the galaxy isn't a frontier to be conquered. It is a vast, inhospitable desert separating a few rare and lonely oases. Each oasis is a solar system, and the intelligent life within it eventually learns the hard truth. Leaving your oasis is a fool's errand. You will die of thirst long before you find another that isn't already occupied by someone else who came to the same conclusion. Visualize a generation ship, a colossal vessel carrying the hopes of a species. It pushes away from its home star, accelerating for centuries, but with every light year it crosses, the dream fades. The ship's systems, unimaginably advanced, still degrade over millennia. The society inside, meant to be a seed, turns inward, its culture fracturing under the strain of endless journey. They are not conquering the void, they are being dissolved by it, and for what? A distant, dim star that offers no guarantee of a welcome. Only another set of impossible challenges. The rational choice made by countless civilizations before they ever launch a single ship is to turn off the engines, to look inward, not outward. The universe appears empty because ambitious civilizations are not out there colonizing. They are at home, having run the numbers and quietly closed the shutters. The silence isn't fear, it is the sound of ultimate practicality. This ultimate practicality leads to a final, deeply human filter. The stars might be reachable, but the will to reach them could be the rarest resource of all. We think of exploration as an innate drive, a fire that burns in every intelligent species. But what if that fire simply goes out? This is the psychological barrier, a sociological filter more subtle than any weapon or machine. Imagine a civilization that has solved its fundamental problems. Hunger, disease, even mortality are relics of a distant past. Energy is limitless, drawn directly from its star, and its greatest achievement is not a starship but a perfected reality. Its people live in a symphony of experiences crafted by artificial intelligences of godlike empathy. Every fantasy can be lived, every curiosity satisfied, every connection made in a virtual realm of infinite depth and beauty. The physical world is maintained by silent, efficient machines. There is no struggle, no unmet desire, no unknown frontier at home. Now, present that civilization with a proposal. We must build a vessel that will take 1,000 years to reach another star. The journey will be perilous and lonely, lived in cramped metal halls. The destination is a barren rock that will require centuries more of brutal labor to make habitable. All to plant a flag in a silent desert. The vote would be unanimous. Why? The drive to explore, to colonize, to push outward is not a universal law. It is a product of need, of curiosity, of discontent. Remove those and the engine of expansion sputters and dies. The silence we hear may not be the silence of extinction or hiding. It may be the silence of a universe filled with civilizations that have all gone indoors forever. Picture the contrast. On one hand, a city planet, a glittering jewel wrapped in layers of dazzling light and information, its inhabitants' minds dancing through realities of their own design. On the other, a single, dark generation ship, a speck of frozen metal drifting between the stars, carrying a forgotten dream from an age when people still looked up and felt a longing they could not name. The ship is a museum piece, launched by ancestors whose motivations seem quaint and painful to their blissful descendants. The cosmos is empty because every civilization that could fill it eventually builds a better cosmos inside a computer and loses all interest in the cold, dark original. The final great filter isn't a catastrophe, it is comfort. It is the point where a species answers the ultimate question, why go out there, and finds it has no good answer anymore. Comfort might not be the final stop on this journey. There is another destination, one of breathtaking patience and cosmic scale strategy. It is called the Eastivation hypothesis, and it reframes the silence as a collective, deliberate pause. The universe is not empty because civilizations have died out or turned inward. It is empty because everyone is waiting. They are waiting for the universe itself to become a better place to live. Right now, the cosmos is a warm, bustling place. Stars blaze, cosmic background radiation fills every cubic inch of space with a faint heat, and particles jostle with energy. For a civilization that thinks not in centuries but in billions of years, this is a problem. Heat is the enemy of computation. The warmer your environment, the more energy you waste just overcoming noise and errors in your most advanced thinking machines. For a mind that has grown to encompass planets or stars, a mind that thinks in calculations of unimaginable complexity, this background warmth of the young universe is like trying to solve the deepest mysteries of existence in a roaring, crowded room. So what do you do if you are advanced enough? You make a calculated decision. You go to sleep. You enter a state of cosmic hibernation, or more precisely, Eastivation. You power down your vast megastructures. You put your collective consciousness or your governing artificial intelligences into a state of ultra-low energy suspension. You set an alarm clock for when the universe has naturally expanded and cooled to a far more optimal temperature, perhaps 100 billion years from now. In that far future era, the background heat will have faded to a whisper. Stars will have burned out, and the cosmos will be a dark, cold, and profoundly quiet place. And in that cold, computation becomes almost infinitely more efficient. Every joule of energy you stored from your home star eons ago can be used for pure, flawless thought, for simulations of staggering depth, for realities crafted with perfect precision. The waiting is not a sacrifice, it is an investment. The emptiness we see today under this hypothesis is not a sign of absence, it is a sign of universal consensus. Every civilization that reaches a certain level says the same thing. This era is too hot, too noisy, too inefficient. Let us pause, let us conserve our resources and our consciousness. Let us wait for the universe to ripen. Imagine looking out at a star surrounded by a dormant Dyson sphere. It is not dark because the civilization died. It is dark because they have perfectly insulated their star's energy, banking it like a cosmic savings account, and gone into stasis. The galaxy could be filled with such sleeping giants, each one a vault of potential, silently counting down the eons until the Great Awakening. The silence we hear is the sound of a universe holding its breath. We are not shouting into an empty graveyard or a dark forest. We are whispering in a library where every other reader has put down their book, closed their eyes, and decided to wait for the perfect, silent conditions to truly understand the story. Our entire civilization, from its first spark to this very moment, is just a flicker in the long, quiet afternoon of a universe that has decided to take a nap. So where does this leave us, staring into a void filled with so many terrifying possibilities? Theories are one thing, but the universe occasionally offers us a riddle, a data point that refuses to fit neatly into any box. These are the glimmers in the data, the unexplained anomalies that force us to ask with a fresh chill if we are truly alone. The first of these modern mysteries began with a star over 1,000 light-years away in the constellation Cygnus. Catalogued as KIC 8462852, but now famously known as Boyajian star or Tabby's star, it was discovered by the Kepler Space Telescope, which stares at stars to detect the telltale, rhythmic dimming caused by planets passing in front of them. But this star did not behave. Its light curve, the graph of its brightness over time, was unlike anything ever seen. Instead of the gentle, predictable dips of an orbiting planet, the star's light would plummet by enormous amounts, up to 22% in chaotic, jagged patterns. It would stay dim for days, then partially recover, only to drop again in a different shape. Imagine watching a familiar porch light across a vast field. Normally it's steady, but one night it flickers wildly, sometimes almost going out, then surges back, all in erratic, nonsensical patterns. That was Tabby's star. Astronomers scrambled for natural explanations. A swarm of comets, the debris of a shattered planet, dust from some colossal collision. Each idea stretched known physics to its limits. The dimming was simply too extreme, too irregular. The shadow passing in front of that star was not a clean, round planet. It was something monstrously big and shockingly uneven, something that should not exist. And so, quietly, another hypothesis entered the conversation. Could it be artificial? The most famous speculative structure is a Dyson swarm, a vast collection of energy-capturing panels orbiting a star. Such a megastructure would not be a solid shell, but a ragged, incomplete collection of shapes casting strange and variable shadows. The data from Tabby's star, while never confirming this, never fully ruled it out either. The terror of this anomaly is not in proof, but in profound ambiguity. It is the universe presenting us with a star that winks at us in a code we cannot decipher. Is it a natural wonder we do not yet understand? Or is it the first flickering campfire we have seen in the dark forest, its light partially obscured by the movements of its builders? Then, in October 2017, a second puzzle arrived from the interstellar deep. Our telescopes detected a visitor. It was not a comet from our own solar system. Its speed and trajectory were unmistakable. This was an object from another star, the first we had ever seen. We named it Oumuamua, a Hawaiian word meaning scout or messenger from the distant past. It was small, perhaps a quarter-mile long, and tumbling through our neighborhood, but its properties were bizarre. Its shape, inferred from its changing brightness, was extreme. It was long and thin, like a cigar or a pancake, 10 times longer than it was wide. Nature tends to make rough, lumpy objects. Such a precise, elongated form is unusual. More puzzling was its motion. As it sped away from the sun, it accelerated slightly, as if pushed. Comets do this when their ices heat up and vent gas, forming a visible tail. But Oumuamua showed no coma, no tail, no dust cloud. It was dark, reddish, and utterly dry-looking. So what gave it that nudge? The pressure of sunlight itself is a faint force, but for an object that is extremely thin and light, it could act like a sail. This led to the startling suggestion that Oumuamua could be a light sail, a piece of ancient technology drifting between the stars, a derelict probe, or a discarded fragment from a civilization long gone. Again, astronomers favor natural explanations, perhaps a chunk of exotic hydrogen ice that vented invisibly, or a rare type of rocky fragment, but the peculiarities linger. It was an odd duck by every measure. These two anomalies, Tabby star and Oumuamua, represent a new kind of cosmic fear. It is not the fear of a clear and present danger, but the fear of the maybe. The data is real, the strangeness is undeniable. The most likely answer is always an unknown natural phenomenon, but the door is now and will forever be cracked open. Because the true terror lies in the possibility that we are not just theorizing about ghosts in the machine. We might be starting to see their faint, distorted shadows on the cave wall, shadows cast by something we are not yet equipped to recognize. Perhaps the most radical explanation for the silence turns the entire problem inside out. What if the universe isn't empty for a physical reason, but for a practical one? What if the cosmos feels hollow because it is, in a very literal sense, unfinished? This brings us to the simulation argument proposed by philosopher Nick Bostrom. It begins with a startling premise that advanced civilizations would likely possess computing power so vast it would be indistinguishable from magic to us. With that power, they could run incredibly detailed simulations of entire universes, populated by conscious beings who believe their reality is real. Bostrom suggests that if such simulations are possible, and if such civilizations have any interest in running them, then the number of simulated minds would vastly outnumber the biological ones. Statistically, we are more likely to be one of those simulations than an original biological being. Now, apply this logic to the emptiness we see. In a simulation, every star, every galaxy, every cubic light-year of space requires processing power. Rendering a completely full, bustling universe in perfect detail would be an astronomical computational burden, even for a super-advanced civilization. So what do? You take shortcuts. You only render the parts that are being observed. You populate the simulation sparsely, focusing your processing budget on the interesting parts, like a planet where intelligent life is developing. The vast, empty stretches between galaxies, they are not explored, so they can remain low-resolution, mere placeholders. The eerie uniformity of the cosmic microwave background. That could be a repeating texture, a default skybox. The Fermi Paradox finds a chillingly simple answer here. The universe is empty because the programmers did not bother to fill it. They are not simulating a full cosmos for us to explore. They are simulating a stage for us to perform upon, and the rest is painted scenery. The terrifying implication is that our entire reality, from the atoms in our bodies to the most distant quasar, is an artifact. A product. The loneliness we feel when we look up is not a condition of a natural universe, but a design feature of an artificial one, built by entities whose motives we cannot fathom. Are we an experiment, a form of entertainment, a historical archive? The silence is the hum of the server, and the void is the blank canvas they chose not to paint. But a simulation still follows rules, even if they are programmed ones. What if the universe's rules themselves are the problem, not with malice, but with brutal, cyclical indifference? There is a clock ticking in the heart of our galaxy, and its alarm resets the board for life every few 100 million years. This is the theory of periodic cosmic cataclysms, a grand and terrifying cycle of death and rebirth that could answer the great silence with a simple, chilling truth. Everyone keeps getting wiped out on schedule. Think of the Milky Way not as a stable home, but as a beautiful but dangerous machine. It has rhythms and eruptions built into its very structure. The most devastating of these might be gamma-ray bursts. These are the universe's most powerful explosions, beams of concentrated energy so fierce that a single burst from a nearby star could strip the ozone layer from a planet like Earth in an instant, bathing its surface in lethal ultraviolet radiation. A gamma-ray burst pointed in our direction from within a few thousand light-years would be an extinction-level event of cosmic proportions. Now imagine that such events are not freak accidents, but regular occurrences on a galactic timescale. As stars are born and die in the spiral arms, the conditions for these monstrous explosions recur. A civilization could rise to greatness, look to the stars, and be erased in a flash of light it never saw coming, its radio signals dying in the static of its own atmosphere boiling away. But the danger might not come from random stars in the arms. It could come from the very center of the galaxy itself. Our Milky Way has a supermassive black hole at its core, Sagittarius, a star. It is mostly quiet now, but evidence suggests that eons ago it was an active galactic nucleus, a quasar, blazing with radiation as it devoured matter. Such an outburst would flood the galaxy's central regions with X-rays and cosmic rays, sterilizing thousands of light years in every direction. These outbursts may be cyclical, tied to the flow of gas into the galactic center. Every few 100 million years, the core might wake up, and a wave of deadly radiation sweeps through the spiral arms like a scythe. Even without a quasar, the simple motion of our solar system could be our doom. As we orbit the galactic center, we do not travel on a flat plane. We bob up and down through the disk of the galaxy. During these oscillations, we pass through the denser spiral arms and the galactic plane itself, regions crowded with more stars, more molecular clouds, and a far higher chance of encountering a supernova or being nudged by a passing star's gravity, sending comets raining into the inner solar system. Some scientists have even found correlations between these galactic passages and mass extinction events in Earth's own fossil record. The universe, in this view, is not a safe harbor. It is a shooting gallery, and every few 100 million years our ticket gets called. Visualize it, a wave of energy, visible only as a distorting shimmer in the fabric of space itself, expands from the galactic core. It travels at the speed of light, unstoppable and silent. It washes over star systems in the inner galaxy. On a world orbiting a yellow star, a civilization is at its peak. Their cities glow on the night side of their planet. Their telescopes are listening. Their dreams are of the stars. The wave arrives first, their satellites fry. Then their atmosphere lights up with auroras of death. The radiation spikes, mutating DNA, killing crops, collapsing ecosystems. Within a year, the civilization is gone. The wave continues outward through the spiral arms, resetting the clock for life on 1,000, a million worlds. By the time it reaches the outer reaches where we reside, it has weakened, or perhaps we are just in a lucky lull between pulses. This transforms the cosmic emptiness into something profoundly tragic. The silence is not a sign of failure or fear. It is the quiet between storms. We are not in a graveyard of those who destroyed themselves. We are in a field where the harvest is regularly, inevitably, scorched by fire from the sky. Every civilization is a tender shoot that grows in the brief spring, only to be cut down by the cosmic winter before it can seed other worlds. The window of opportunity for a species to arise, become intelligent, develop technology, and then reach out to others is not defined by its own wisdom. It is defined by an astronomical calendar it cannot control. We might be living in one of those fragile, golden windows right now. Our planet has been relatively stable for hundreds of millions of years, long enough for complex life to evolve and for intelligence to finally emerge. But for how much longer? Is the next cataclysm already on its way? A gamma ray burst from a doomed star hundreds of light years away, its lethal beam already crossing the void toward us. Or are we in a safer suburb of the galaxy, far enough from the dangerous core to have a longer, but still finite, lease on life? This idea makes the Fermi Paradox feel less like a mystery and more like a symptom. The galaxy isn't empty because civilizations are hiding or transcending. It's empty because the universe is a place of periodic, sterilizing violence. Life keeps getting a chance to start the race, but the track is routinely cleared before anyone can reach the finish line. We are not shouting into a dark forest. We are whispering in a valley that we know, from the geological record of countless worlds, is prone to catastrophic floods, and the distant rumble of thunder might already be echoing in the void, a reminder that our time here, and the time of anyone who might hear us, is borrowed from a clock we did not set. Our entire search for cosmic company rests on one fragile assumption. We assume that anyone out there would want to talk to us and that they would do it in a way we can understand. This might be the most naive mistake of all. We are listening for a radio whisper in a universe that may have moved on to conversations we cannot even perceive. Think of the technology gap. A mere 200 years ago, the most sophisticated long-distance communication on Earth was a semaphore tower or a fast horse. If someone from that time were told that invisible waves carrying voices and images were constantly passing through their body, they would call it magic. They could build the most sensitive telegraph in the world and never detect a television broadcast. We are in that exact position now. We point our giant radio dishes at the stars, listening for deliberate, narrowband signals, a cosmic hello on a frequency we can decode. But what if that's like using a smoke signal to try and get the attention of someone video calling from a skyscraper? An advanced civilization a million years ahead of us wouldn't use radio for interstellar chat. It's slow, it degrades over distance, and it's terribly inefficient. They would have mastered the fabric of reality itself. Their messages might be encoded in subtle ripples in space-time, in gravitational waves we are only just learning to detect. They might use neutrinos, ghostly particles that pass through entire planets as if they weren't there, creating a network that is private, instant, and unaffected by cosmic dust. Or their communication could rely on quantum entanglement, a phenomenon Einstein called spooky action at a distance, where particles linked across light years share information instantly. To us, that's a laboratory curiosity. To them, it could be the backbone of their internet. The terrifying and humbling possibility is this: the cosmos is not silent. It is roaring with conversation. We are simply deaf to it. We are standing in the middle of a bustling digital metropolis, holding up a tin can on a string, wondering why no one is talking to us. Every pulsar's steady beat, every burst of gamma rays, every mysterious emission from a distant nebula could be part of a data stream, a news broadcast, or even art, flowing on a carrier wave of physics we haven't yet discovered. Our SETI programs scan a tiny sliver of the radio spectrum, a narrow ditch beside an ocean of potential information. It would be a miracle if we happened to tune into the right channel at the right moment to catch a signal meant for someone or something else. The silence we perceive is not an absence of sound. It is a failure of our senses. We have built exquisite ears, but we are listening for the wrong kind of whisper in a hurricane of other languages. This deafening silence, this ocean of languages we cannot hear, is only half the prison. The other half is the bars themselves, forged not from ignorance but from the unbreakable laws of physics. The universe is empty for one brutally simple reason. It is too big, not just big in a way that inspires awe, but big in a way that crushes ambition and enforces a permanent, solitary confinement. This is the tyranny of distance, the ultimate cage built by Einstein's theory of relativity. The speed of light is not just a limit, it is a prison warden. Nothing, not information, not matter, not a simple hello can travel faster. That number, 186,000 miles per second, seems unimaginably fast to us. On Earth, it is instantaneous, but across the desert between stars, it is a crawl. Let's make this painfully concrete. Our nearest stellar neighbor is Proxima Centauri, a faint red dwarf. It is 4.2 light-years away. That means a beam of light, the fastest thing in existence, takes 4.2 years to make the trip. A radio signal saying, "We are here," would take over 4 years to arrive. If someone there heard it and replied immediately, we would not get their answer for another 4 years. A single exchange of greetings would take longer than a presidential term. That is our next-door neighbor. Now expand that to the scale of our galaxy. The Milky Way is 100,000 light-years across. A signal sent from one edge would take 100,000 years to reach the other. To put that in perspective, 100,000 years ago, our ancestors were just beginning to migrate out of Africa. Modern humans did not exist. If a civilization at the far rim of the galaxy broadcast a welcome message then, we would only be receiving it now. And our reply would take another 100,000 years to crawl back to them. A single conversation would span 200,000 years. Human civilization from the first cities to today is only about 10,000 years old. One dialogue would last 20 times longer than all of recorded history. The idea of a galactic community, of trade, of diplomacy, of shared culture shatters against this timescale. It is utterly impossible. Imagine trying to build a nation where every letter between cities took 10,000 years to deliver. The message would arrive to find the city it was sent to had long since crumbled to dust, its people forgotten, its language extinct. This is the reality of interstellar space. Civilizations are not just separated by empty space. They are isolated by deep time. They are islands in an ocean so vast that by the time a bottle with a message washes up on a distant shore, the civilization that cast it has been gone for millennia. The emptiness is not an accident of cosmic evolution. It is enforced. The physics of our universe have built walls of time and space that are fundamentally unbreachable. We are not just alone, we are permanently, irrevocably quarantined by the architecture of reality itself. These unbreakable walls of time and space are not the only prison. There is another cage, one we carry with us everywhere we go. It is our own biology. The dream of spreading humanity to the stars crashes into a brutal physical reality. We are not just creatures of Earth, we are exquisitely, delicately products of it. Every cell in your body is calibrated to a specific gravity, a specific mix of atmospheric gases, a specific magnetic field, a specific rhythm of day and night. Space is not just empty, it is actively hostile to every one of those calibrations. Consider what just 6 months on the International Space Station does to an astronaut. Their bones, no longer fighting gravity, leach calcium and weaken, losing mass at a rate of 1 to 2% per month. A journey to Mars lasting years could leave explorers with the skeleton of an elderly person prone to fractures. Muscles atrophy without constant resistance, turning to flaccid tissue. The heart, a muscle itself, weakens and changes shape. Fluids in the body, no longer pulled downward, shift toward the head, causing chronic sinus congestion, a puffy face, and increased pressure on the eyes that can permanently damage vision. Then there is the radiation. On Earth, our atmosphere and magnetic field shield us from a constant hail of cosmic rays and solar particles. In deep space, there is no shield. Astronauts report seeing flashes of light behind their eyelids, caused by high-energy particles tearing through their retinas and brains. This radiation doesn't just increase cancer risk. It bombards the brain itself, with studies showing potential for accelerated dementia, memory loss, and impaired decision-making. A crew on a multi-year journey might arrive at their destination with their cognitive abilities, their very personalities subtly eroded. And this is just the trip. The destination is worse. Mars has only 38% of Earth's gravity. What does a human pregnancy look like in that environment? How would a child's bones and muscles and circulatory system develop in a partial gravity we have never studied? Would they ever be able to visit the homeworld their ancestors came from, their bodies too frail for its crushing weight? Now, imagine a civilization that has faced these same facts. They looked at the stars with the same longing, built their rockets, and then ran the biological equations. The conclusion is inescapable. To truly live out there, you cannot take your body with you. You would have to leave it behind. A species that wishes to colonize the galaxy must first cease to be what it is. It must engineer itself into something new. Perhaps they would grow beings in artificial wombs designed from the genome up for high radiation tolerance, for low gravity, for a methane atmosphere. They would be as alien to their creators as a deep sea fish is to us. Or perhaps they would abandon biology altogether, uploading their consciousness into durable robotic bodies or virtual worlds, sending only these digital seeds to the stars. In that moment, the dream of spreading life becomes something else. It becomes the spread of intelligence or memory or data. The original biological civilization remains at home, a fragile, beautiful flower in its one perfect pot, while its engineered thoughts travel the void. The cosmic emptiness, then, is a mirror. It shows us that biology is not a universal force. It is a local condition. Life may spark on countless worlds, but it is forever rooted in the soil of its origin, shaped by its specific gravity, its star's light, its atmospheric cocktail. To reach another pot requires becoming a different plant altogether. The silence we hear may be the sound of a million different kinds of life, each singing a beautiful, complex song of existence, but every song is trapped in its own cathedral, its acoustics never designed to carry across the vault of heaven. We are listening for an echo in a universe where every voice is perfectly, tragically, adapted to its own room. This profound isolation forces us to confront a question far deeper than physics. If the void truly is empty, what does that mean for us? For millennia, our stories, our religions, our very sense of purpose have been woven from the assumption that we are part of something larger. We gazed at the stars and saw gods, ancestors, or future companions. We were players in a cosmic drama, but what if the curtain rises and we find the theater is empty? The audience seats stretch into infinity, dark and vacant. There is no one watching, no one to applaud, and no one waiting in the wings. We are the only actors on a stage lit by a single star, performing a play for which there is no script and no one to remember the lines. This realization carries an existential weight that can crush or liberate. For some, it is the ultimate recipe for despair. If we are alone, then all of human struggle, our art, our love, our wars, our quiet moments of kindness, are just a fleeting chemical flicker in an indifferent void. They mean nothing to the universe. Our planet becomes not a cradle, but a solitary, fragile egg balanced on a mountain of nothing. In this view, the cosmic silence is the sound of nihilism, a vacuum that sucks all meaning from our endeavors. Why build, why create, why strive, if it all ends in the same eternal, uncaring dark? Yet there is another way to hear that same silence. It can be the most powerful call to stewardship ever issued. If we are the universe's only thought, its only chance to know itself, then everything we do matters infinitely. This planet is not just our home, it is the sole library in a universe of blank pages. Every extinct species is a chapter lost forever. Every polluted river is a sentence erased. The responsibility is terrifying, but it is also sacred. We are not just caretakers of Earth. We are the curators of the only known gallery of beauty, the only archive of consciousness in all of creation. That candle in the dark cathedral is not a sign of loneliness, but a declaration. It says, here there is light. Our art, our science, our compassion are not meaningless. They are the universe's only meaning. We get to decide what the story is about. The emptiness is not a judgment. It is a blank canvas, and we hold the only brush. This shifts our quest from a search for neighbors to a mission of legacy. Do we become the civilization that looked into the abyss and let its own light go out? Or do we become the ones who nurtured that flame, who protected the tiny, warm island of life in a sea of cold, silent space, so that one day our story might be found not by others, but by our own descendants, who will understand the precious, staggering rarity of what we kept alive? The silence asks us the most important question we will ever face. In the absence of any audience, what kind of performance will we choose to give? Perhaps the most unsettling answer is that all of these horrors are true, layered one upon the other like a cosmic gauntlet. The universe is not empty for a single, simple reason. It is silent because of a series of filters, each more daunting than the last, a multi-stage extinction event for civilizations. Imagine the timeline of a species that dreams of the stars. The first and greatest hurdle is simply being born. The leap from inert chemistry to that first spark of life, and then from single-celled simplicity to complex, multicellular cooperation, may be a miracle so rare it stops the vast majority of potential life before it even begins. This is the first great filter, and it is a statistical wall. But let's say a species, through impossible luck, clears it. They evolve intelligence, discover tools, and look to the heavens. Now they face the second layer, their own technology. This is the adolescence filter, the point where a species gains the power to destroy its own biosphere through war, pollution, or engineered catastrophe. Countless civilizations may have ended here, snuffing themselves out in a flash of pride or fear. Yet a handful survive, learning to manage their own destructive potential. They achieve stability and they finally reach out. This is when they encounter the third and perhaps most chilling layer, the dark forest. The galaxy is not a welcoming place. It is filled with other survivors of those first two filters, all paranoid, all armed, all following the same ruthless logic. The first civilization to detect a new, noisy neighbor does not send a greeting. It sends a weapon, a silent, relativistic projectile or a tailored virus, erasing the newcomer before they can become a threat. This layer enforces a permanent, terrified silence. But what of the civilizations that survive even this, the ones who learn to hide perfectly or who become the apex predators of the galactic woods? They may face the final, philosophical filter. Transcendence. After eons of struggle, having mastered their world and navigated a galaxy of hidden knives, they achieve a technology so profound that the physical universe feels like a prison. They turn inward, uploading into digital heavens or higher dimensions, leaving the cold, dangerous stars behind forever. The emptiness we see, then, is the product of this layered horror. It is the silence of countless worlds that never sparked with life, plus the silence of those that burned out in their own fire, plus the silence of those that were silently culled by unseen hunters, plus the silence of those who finally left the building altogether. We are not looking at one graveyard. We are looking at an archaeological dig with layers of extinction stacked over billions of years. Each theory we explored is not an alternative. It is a consecutive chapter in a single, terrifying story. The cosmic void is not just empty. It is a monument to a series of near-impossible escapes, a testament to how many ways a dream of the stars can die. Our civilization right now is somewhere on that timeline. We have passed the miracle of our own biology. We are currently wrestling with the technology of our self-destruction. And we are beginning to shout into the forest, unaware of what might be listening. The true terror is not knowing which layer we are facing next. The terrifying weight of all these possibilities now lands squarely on our shoulders. We have mapped the cosmic graveyards and the dark forests, but the most urgent question is not out there. It is right here. Are we, humanity, on a trajectory to become just another day to point in the great silence? Our own story is still being written, and the early chapters are deeply troubling. We emerged from the trees with curiosity and cooperation, but also with a capacity for breathtaking violence and short-term thinking. We built civilizations and then used our new knowledge to build weapons capable of erasing them. The mushroom cloud, that iconic symbol of the 20th century, is not just a political statement. It is a candidate for a great filter, a technological adolescence so dangerous that most species may not survive it. We have come perilously close to triggering it ourselves, not once but multiple times. Our drive for growth has also led us to ravage the very biosphere that cradled us, altering the climate and triggering a mass extinction event. From a cosmic perspective, these are the classic symptoms: aggression, resource exhaustion, environmental collapse. We are checking every box on the list of behaviors that could lead to a silent, solitary end. Yet, in the very same breath, we demonstrate a countervailing brilliance. We sent the Arecibo message in 1974, a deliberate shout into the void containing the basics of our biology and our location. Was that naive? In a dark forest universe, it was arguably reckless, but it was also an act of profound hope, a declaration that we choose to believe in community over fear. We have created institutions for peaceful cooperation, from the United Nations to international scientific collaborations like CERN and the International Space Station, where former rivals live and work together in orbit. We point our telescopes outward not just to conquer, but to understand. We are a species of terrible paradox, capable of creating stunning beauty and inflicting horrific suffering, often within the same generation. This duality is our test. The cosmic patterns suggest that one side of our nature must ultimately win. Will our fear and tribalism turn us into the paranoid hunters, or will our empathy and curiosity allow us to become the wise elders? Our next steps will decide. The silence of the universe is not just a mystery to be solved. It is a mirror, and it is a warning. Every decision we make about our planet, about each other, about our technology, echoes in that void. Are we listening to the echo of our own potential demise, or are we hearing the first faint notes of a different song? The universe has presented us with a riddle written in emptiness. Our response will not be a radio signal. It will be the story of our survival, the proof that a species can look into the abyss, see all the ways to perish, and still choose to light a candle instead. The next chapter is ours to write, and every single one of us is holding the pen. And so we look, in the face of all that silence, all those terrifying possibilities. Humanity has made a choice. We have chosen to answer the void not with despair, but with a question of our own. Are you there? The scientific quest for an answer has a name: SETI, the search for extraterrestrial intelligence. For over 6 decades, this has been a quiet, persistent rebellion against the cosmic quiet. It began in earnest in 1960, when a young astronomer named Frank Drake pointed the 26-meter Tatel radio telescope in Green Bank, West Virginia, at 2 nearby sun-like stars. Project Ozma listened for a few hundred hours, hearing only the natural hiss of the cosmos. It was the first deliberate, modern attempt to scan the heavens for a signal, and it set a precedent. The search must be active. We must reach out with our ears. Today, that search has evolved into a colossal, coordinated effort. The most ambitious of these is the Breakthrough Listen Initiative, a 10-year, $100 million program that is essentially turning some of the world's most powerful telescopes into cosmic eavesdroppers. It uses the Green Bank Telescope in West Virginia, the Parkes Observatory in Australia, and others to systematically scan the million closest stars to Earth, the center of our galaxy, and even 100 nearby galaxies. The scale is almost incomprehensible. Breakthrough Listen processes more data in a single day than earlier SETI projects did in a year. It is listening across a broad swath of the radio spectrum and also looking for brief, powerful laser pulses that could be an interstellar beacon. But the search is no longer just for a deliberate hello. Scientists are now hunting for something broader, something called technosignatures. These are not messages, but the inevitable byproducts of a technological civilization, signs we might detect even if no one is trying to talk to us. It is the search for evidence, not conversation. The most famous technosignature is the Dyson sphere, or more realistically, a Dyson swarm. The concept proposed by physicist Freeman Dyson imagines an advanced civilization capturing the entire energy output of its star with a vast shell or cloud of orbiting collectors. From a great distance, such a star would look bizarre. It would glow not in the familiar spectrum of a sun, but in the infrared, as the megastructure absorbed visible light and re-radiated it as waste heat. Astronomers now routinely sift through data from telescopes like NAS, a wide-field infrared survey explorer, looking for stars with exactly that strange infrared signature. A few candidates have emerged, like the mysterious Tabby star we discussed, though natural explanations are always more likely, but technosignatures could be far more subtle. Imagine pointing a future, incredibly powerful telescope at a distant exoplanet. We are already learning to analyze the light filtering through a planet's atmosphere to determine its composition. What if we saw signs not of life but of industry? Chlorofluorocarbons, the chemicals that once threatened Earth's ozone layer, do not occur naturally in any significant amount. Detecting them in an alien atmosphere would be a near certain sign of technology, or perhaps we would see an unnatural imbalance of gases, a pollutant signature that screams of a civilization burning its own version of fossil fuels. We might even detect city lights on the night side of a world, or the glint of vast solar panel arrays in orbit. Every new telescope, like the James Webb Space Telescope, is not just a window into the past. It is a tool for this new kind of detective work, scanning the cosmic crime scene for fingerprints we were not even looking for a generation ago. Picture the scene at a radio observatory on a clear, cold night. The massive dish, a parabola of metal larger than a football field, tilts silently against the star field. It is not collecting light, it is listening. Its focus is on a single, unremarkable point of light, a star hundreds of light years away. For hours, it drinks in the radio noise from that patch of sky. The data streams into banks of computers where algorithms sift through the cosmic static, searching for a pattern that is too regular, too narrow, too perfect to be natural. The pulse of a pulsar is natural. The drifting signal from a gas cloud is natural. The search is for the anomaly, the spike in the data that says this was made. Night after night, year after year, this ritual repeats, and so far the headphones of our species have heard only silence. Yet we keep listening. That is the crucial point. The search itself is the act of defiance. In a universe that might be a dark forest, we are choosing to stand up and whisper, even if it risks attracting predators. In a universe that might be a sterile desert, we are choosing to dig for water, believing an oasis must exist. In a universe that might be a simulation, we are testing the boundaries of our cage, poking at the code. Every minute of telescope time, every line of code written to analyze data, every young scientist dedicating their career to this long shot is a vote for a particular kind of cosmos. It is a vote for a universe where curiosity and connection are stronger forces than fear and isolation. The fact that we look, despite every reason to believe we might find nothing or something terrifying, is one of the most hopeful things our species does. It proves that the human spirit contains a drive that mirrors the theoretical drive of those transcended civilizations, but pointed outward. We are not ready to turn inward yet. We still want to know if anyone is home. This search is our way of answering the silence with a promise. We are here and we are paying attention. This profound loneliness, this vast and silent cradle, might be the greatest gift the cosmos has ever given us. Every terrifying theory we have explored carries a hidden blessing within its dread. Consider the alternative. Imagine a galaxy pulsing with advanced life, a crowded cosmic metropolis. If another civilization had arisen just 1 million years before us, a mere blink in galactic time, their technological lead would be godlike. Upon discovering our primitive world, buzzing with promising but noisy life, what would their policy be? In a universe of finite resources, we would not be neighbors. We would be pests, or at best, a curious exhibit. The dark forest would have been our immediate reality, not a distant theory. Our evolution would have been cut short before we ever learned to shape a stone into a tool. The very emptiness that unnerves us is what made us possible. It provided the isolation necessary for a slow, uninterrupted, and breathtakingly unlikely experiment to unfold over 4 billion years. That experiment is us. Every predator we outsmarted, every climate shift we endured, every star we mythologized happened in a quiet laboratory. No passing alien survey ship reset the experiment. No interstellar war scorched our atmosphere. We were left alone to stumble, to learn, to grow. This void is not a prison sentence, it is a grant of asylum. The immense distances between stars, those cruel barriers that seem to quarantine us, also act as a buffer, a moat protecting our island of life from any potential storm. The cosmic shooting gallery we fear is, by its very rarity, a testament to our incredible luck. The cataclysms that could have sterilized us, the gamma-ray bursts, the nearby supernova, have thus far passed us by. We exist in a pocket of profound peace, a backwater so quiet that a fragile species of talking apes could emerge and start asking questions about the silence itself. Visualize Earth not as a lonely outpost, but as a hidden garden. Outside the walls, the theoretical universe might be a savage jungle of competition and ancient, ruthless intelligence. But inside, for billions of years, the sun has warmed the soil, the rain has fallen, and life has woven itself into ever more complex and beautiful forms, utterly unmolested. The darkness beyond the garden wall is not what threatens us, it is what has always protected us. The void is the fence, so when you next feel a chill looking up at the starry expanse, try to feel a different sensation. Or yes, but also gratitude. That terrifying emptiness is the reason you are here to be terrified by it. It held the space for our story. Every dream we have of reaching those stars is only possible because they have, until now, remained perfectly, mercifully out of reach. The universe gave us a safe room in which to be born and a window through which to dream. The silence is not a verdict of our unimportance, it is the condition of our existence. Our cosmic loneliness is not a curse, it is our inheritance, and it is time we started treating it with the reverence it deserves. And yet, for all our searching and all our theorizing, we must confront a humbling possibility. We may never know the true answer. The universe, in its ancient, infinite wisdom, guards its deepest secrets well. This ultimate uncertainty is not a failure of our science or our imagination. It is woven into the very fabric of our condition. We are finite beings trying to comprehend the infinite, temporary minds reaching for eternal truths. The silence may hold a dark forest, or a pristine desert, or a chorus of voices we are too primitive to hear. We may spend the next 10,000 years listening and find only that same vast quiet. And that is okay. This unresolved mystery is part of the profound, terrifying beauty of our existence. It means the story is not over. The final chapter has not been written because we are still here to write it. Our quest for meaning in that silence, our refusal to accept loneliness as the final word, is what defines us. It is the spark that built our telescopes and composed our symphonies, the drive that pushes us to care for our fragile world and dream of others. So the next time you find yourself under a clear night sky, I encourage you to do something simple. Just look up, sit with that feeling of awe, that vertigo of the unanswered question. Let the immensity wash over you, not with fear, but with a quiet reverence. You are part of the mystery you are trying to solve. Contemplate the Hubble Ultra Deep Field image, that deepest portrait of the cosmos ever taken. In that single grain of sand-sized patch of sky, there are thousands of galaxies, each one a swirl of hundreds of billions of stars, each star a potential sun for other worlds. And within those worlds, an infinity of potential stories of lives lived, civilizations risen and fallen, loves lost and found. Most of those stories will forever remain untold to us. They are whispers lost in the wind between the galaxies, but the fact that we can see them, that we can wonder about them, that we can feel the ache of their distance changes everything. We are the universe becoming conscious of itself, staring into its own reflection and trying to understand the face looking back. The emptiness is not an end. It is an invitation to keep looking, to keep listening, to keep reaching. Our greatest discovery may not be a signal from the stars. It may be what we learn about ourselves in the quiet while we wait. We have journeyed through a gallery of cosmic horrors, from the silent graveyards of the Great Filter to the paranoid hunters of the dark forest. We have considered civilizations that turned inward, transcending into digital heavens or waiting in cold sleep for a better universe. We have faced the possibility that our reality is a simulation, its emptiness a simple matter of processing power. Each theory is a different answer to the same deafening silence, a different story written in the void. Yet they all converge on one unsettling truth: the emptiness is not an accident. It is a profound clue, the universe's most important message. It tells us that the rise of a civilization like ours is either a miracle, a tragedy, or a test. The silence is the evidence. It speaks of filters we may not have passed, of dangers we cannot see, or of a solitude so complete it redefines our place in everything. This changes what it means to look up. The night sky is no longer just a pretty scattering of lights. It is a mirror, a warning, and a question all at once. That twinkling star is not just a sun. It is a potential tombstone, or a sleeping hunter, or an empty chrysalis. The blackness between them is not just space. It is the canvas of our deepest fears and our most audacious hopes. So tonight, or any night the sky is clear, I urge you to do two things. First, go outside. Look up, let the sheer scale of that silent expanse wash over you. But now, see it with new eyes. See the terrifying, beautiful mystery of it. Feel the weight of that quiet, and understand it as the single most important piece of data we have about our existence. Second, turn your gaze back down. Look at this world, this fragile, bustling, talking rock. See it for what it is in the cosmic context, a miracle of improbable life, adrift in an ocean of silence. It is the only home we have ever known, and the silence tells us it may be the only one we ever get. This knowledge is not a cause for despair, but for a fierce and protective love. Cherish this pale blue dot. Protect its biosphere, its beauty, its potential. In a universe that may be fundamentally hostile or indifferent, our kindness, our curiosity, and our stewardship are not small things. They are everything. They are the answer we give to the silence. So I leave you with this question. After this journey through the reasons for the empty cosmos, which idea stays with you? Does the Great Filter terrify you, or does the rare Earth hypothesis fill you with a sense of sacred responsibility? Does the dark forest make you want to hide, or does it make our own choices for peace feel even more urgent? Share your thoughts in the comments below. Let us continue this conversation beneath the silent stars, and if you want to join more journeys into the cosmic unknown, be sure to subscribe. The universe is full of mysteries, and the greatest one is still the story we are writing right here together on this fragile island of light in the dark.